we conduct more than tests. Otherwise, perform should be modified and repeat modification and analyze again performance. So this is what we can say, trial and error for manual optimization. And what is the simulation-based design? This trial and error, repeat-based design procedure is replaced by using optimization technique. That is automatic optimization. So perform modification is done by computer or CAD and performed using any CFD potential or runs. So we can save time and we can remove the design dependency. Okay, so this is a we say simulation-based design. Okay, next please. So every signal or one signal wants to simulation-based design, but there is some restriction. Why? The speed is not generally accepted, nor is it widely used in practical design. There are several issues to be overcome. Thank you. So in order to what I mean by robust automated grid manipulation, we need this is not easy actually. Okay? And geometry modification. This should be matched with CFD tool at least. And also necessity to account for real design constraints. It is not easy to take into account real design constraints in geometry manipulation in combination with the CFD tool. And this is time consuming as well. And need for CFD skill, at least users should know the CFD, how to use it. And this result is mainly user dependent. That's the problem. Mostly, okay, there are several issues, but most problem is not, the simulation SPD developed so far is not user friendly. Not user friendly. So development friendly, what I mean. Numerical optimization must be as familiar as possible to the system design. Each geometry link, effect of design parameter change should be understood at least by designer or user. Okay. So this is a young design practice. As I mentioned earlier, based on partnership, design office designer change parametric variation, SH variation, section shape variation, bulk and transform variation, this is your parameter, perform parameter by use of one of the tools. Then CFD analysis. If the result is happy, we choose final design and then we conduct model testing. Okay, this is really based on experience and trial and error. Please move. There's an advantage for this and also disadvantage. Advantage is effect of parametric variation is understood. For example, if we change SH variation, the result of this SH variation can be seen on the CW or any CFD result. Next page. And as I mentioned earlier, this advantage is a design dependent reliability problem. Okay, if user run different, depending on user, okay, the result seems to be different, and time and cost still time consuming and cost, not economic. Please forward. And we need, practical optimization scheme. We need to develop. We need to, develop a practical optimization scheme. Please. And as I mentioned, in design office by changing SH curve. Okay, they design. This is one of the examples, and the CP by changing, and this is for fixed displacement. And the section shape, the design verticalized, U or V shape, and pole section shape, U shape or V shape, or modification of burden locally like that. So our the goal of the new program development is use the friendly perform optimizer by adopting the average perform design practices by using of parametric perform modification technique. This is parametric perform modification technique. This is the young design practice. They are not changing lines. They are not changing any the object nowadays anymore. So in combination with the local automatic algorithm, say S2P we use, or global optimization. This is derivative free. Later I will explain more detail. Particular global optimization. So full form modification in first generation, we did like using hand done. Later, this is second generation using Trigon or CAD. And these two computer design software are developed by Korean companies. So some of Korean Shimyak are building this. And finally, this second generation still they modify lines. But final goal is without changing any lines, local offset, by changing form parameters, we can generate perform. If we perform we want. It is not easy. There's a lot of freedom restriction here. Here, there's no freedom at all. So any kind of shape can be generated by changing, object, that kind of thing. But here, because we are changing only form parameter, the restriction of perform modification is limited. You get anything is an advantage, but we have to overcome. Next. This is the brief introduction of all the methods of perform modification. Conventionally, by pattern order, point manipulation or data manipulation, and surface based by nervous or any supply, any property. By changing vertex control, we can generate, we can modify per surface locally. And partial, this is a edit patch perturbation method based on we add some function, edit the function, perturb the function to the original shape. This is a modification function method. Further, we just control form parameter by adding some perturb function. So I will explain these three methods. Okay, and this is other method. Next, please. This is usual CAD approach, okay? That is to modify her surface. This is to modify her geometry through moving vertices. This is the for curve, this is for surface. These vertices are design variable in optimization process. Okay, the number of vertices are increasing, the complete cost is increasing as well. Very flexible, no inherent restriction. But sometimes the curve fairness is not guaranteed. This is one of the disadvantages for it. Many design variables, that means compute cost high. Limitedly applied in local and or appendix optimization. Next please. This is a her modification. Original, the new her form is plus of these two combinations, the old form, and then this perturbed function we can use perturbed patch. This function can be explained, can be expressed anything. But this is our the formulation. We call say that is bell shape. This can guarantee always a full fairness. Okay? By attaching this kind of bell shape function, or three or many, we can generate any kind of geometry we want. Okay? This is the multiplication function method. Based on this, actually, this design